So what exactly are we doing when we do regression? So basically what we have is we have our red points, our measurements. So all the red points that you see here are the things that we have measured, the data that we have. And what we want to do is we want to fit a line through these points that shows basically the average behavior of all the points. By fitting this line, for every point that you have, you obtain what it should be according to the line, according to the model. And that's the green thing that you see here, the predicted value. Yeah? So for this point, if I look at it and I go to the line, yeah, this is what I measured, but according to the line, this is what I should have measured. This is the predicted value. The difference between these two, so the difference between what you actually measured and what you should have measured according to the line, is called a residual. And that's the blue thing that you see here. And these residuals are very important, because how does he fit the line? How does he decide which line is the line that fits your data the best? Well, he decides it by checking the residuals. He will search for the line that gives the smallest residuals. And then to find the line, he needs to have a formula. Yeah? He needs to know what the line should look like. And that's exactly what the formula says. So, and in case of a straight line, the formula looks like this. In that formula, you have the predicted values, the y values according to the line, and you write them in function of the values on the x-axis. Yeah? So that's what the line shows, a relation between the y-axis and the x-axis. So, and what relation? That's what you see here. So we have two parameters when we fit a straight line. The first parameter, a here, represents what we call the intercept. Where does the line cut the y-axis? This is the predicted value when x is equal to 0. So you need to know the intercept, and you need to know the slope. How steep does it go? And that's what b shows here. That's this parameter. That's the slope. So if I increase x by 1, how much do I go up? And once you know the intercept and the slope, you can draw the line. So, and that's basically what he will do. He will try a lot of settings for a and b, and he will stick to the setting that gives the lowest residuals. Then we have the line, we have done linear regression. An example from the real world. So I measured the blood volume in a mouse. Yeah? And this is what came out. This is my measurement, one of my measurements. Yeah? One of the red points. And I'm looking at age. This here, the mouse was 15 weeks old. So this is what is on the x-axis. I measure blood volumes on the y-axis in relation to the age of the mouse. So in linear regression, this is exactly what he will try to model. He will try to find a line that fits my measurements the best. And by fitting that line, he will determine the best setting for these two parameters, a and b. So in this example, a, the intercept is 0.4, and b, the slope is 0.2. And once he knows these settings, he can calculate for every measurement what it should be, the predicted value according to the model, by just filling in. So this measurement has an x of 15, so you fill in x here in the equation. And then you come up with the predicted value. What is the residual? Well, the difference between what I measured and what I should have measured. So in this case, 0.2. And all regression works like this. Yeah? Lowest works differently, but all the other ones work like this. The only thing that's different is the equation. If you do nonlinear regression, you might have an equation that looks more like this, where you have an x squared instead of an x. So to represent an equation or a model in R, you have to use this tilde. The tilde literally means is modeled by. So, and in front of the tilde, you always write what you measured. what you want to model, your measurements. And after the tilde, you write what's on the x-axis. So in our case here, ages. Yeah? This is how you want to model it. You want to model your measurements according to this variable. So both y and x will represent columns in a data frame. So, and the formula is important. And luckily for you, you can set both. You can set a method and you can set a formula for that method. The default method is always this one. It also tells you. So when I do a linear model, yeah, he will tell you, hey, I was using this model. Yeah, y versus x. Y versus x implies that there's just an x in your formula. So it implies that you're literally doing this here.